He's been given the name of all names. Jesus, his name is Jesus. He's been given the name of all names. Jesus, his name is Jesus. He's been given the name of all names.
So, what do you call the last topic?
Jesus, he's been given the name of
Daniela, what do you call the last topic?
Jesus, his name is Jesus. He's been given
Okay, what problem leads to direct and inverse proportion? Okay, today we have to look at simple interest. I want to believe you've been taught simple interest before.
Yes, sir.
Okay, and Isaiah, if you have been taught simple interest before, just wave your hand to the camera and let me see. Isaiah, have you been taught simple interest before? Okay, I think the network. Okay. So we're going to look at a few questions there that will move on to compound interest. To move on to compound interest. So firstly, we have simple interest. Simple interest. Now, when you're talking about simple interest, what does that actually mean before we even talk about examples or formulas or whatever? If I ask you whether you're interested in doing something, that means I'm asking you if you see any benefit of doing it. Yeah, if there's any benefit, then you want to do that thing. And that is where your interest comes in. And you're like, let me show your face. So that's where your interest comes in. For example, if you want to go into a business, if you know that business is not profitable, you are not going to be interested in that business. But if you are sure and certain that you have a lot of profit from that business, then you have interest in it. So simple interest simply means simple profit, while compound interest can mean compound profit from the business. So interest here, I will talk about means profit. So here now, we are going to be talking about money, businesses, trading or saving the money to yield whatever in so amount of time. So let's talk about it now. And the parameters we're going to be using is SI, which is simple interest, equal to PRT over 100, PRT over 100. So that is simple interest, while the SI is the simple interest. SI for simple interest. Simple interest. While the P is the principal. Principal or initial money. Initial money, yes, initial money. And because we're talking about money for business or money for saving now, and the R is the rate of the profit, the rate at which the profit comes in. So rate, that is rate. While the time is just a time, the duration of the business. Hold on. So the T equals time, or you say the duration. Somebody's tampering with that. Is that part? So get that up. Now, simple interest is a principal, rate, and time. Let's look at maybe a question. So let's say we have this question to solve. Sample 1. Find the simple interest on 2,600 naira invested at 2% per annum for 5 years. For 5 years. I think I'm hearing background noise from, but it's faint, but it can be reduced. Isaiah logged out, wants to join again, so you will need to be muted if. So the solution to that comes here. I'm just going to Isaiah, please. Okay, that's better. The solution to that is here. We are using our parameter, which is the interest, equal to principal times rate times time, all over 100. And our principal is the money, initial amount, like we said, that is 2,600. And the rate has been given to be 2%, while the time is 5 years. 5 years. So I say I equal to our principal, which is 26600 times the rate, which is 2, then times the time, which is 5 years, all over 100. So this 100 returns this 100 is nothing. Then we can say 26 times 2, or 2 times 5 is 10, and 10 times, that is 26 times 10, that is 260 naira. That means the interest on the money at that rate is 206 naira. Okay, we can now look at the question in another way. Let's assume we have example 2. Example 2, and it says, at what rate? Okay, example 2. At what rate must 6,000 naira be invested to yield 4,000 naira simple interest in 1 year. In 1 year, or let's change that to 2 years. In 2 years. So at what rate must 6,000 naira be invested to yield 4,000 naira simple interest in 2 years? So here now, we're not looking for simple interest. We've been given the simple interest to be 4,000 naira. Then we've been given the time to 2 years, even the principal also, but we're looking for rate. So in an attempt to find our rate, we're going to just play with the formula and find our rate from the formula, which the formula is I equal to DRT over 100. But here now I'm looking for rate. So I'm going to cross multiply. I have 100I. Cross multiply. 1 times PRT gives me PRT. DRT equal to 100 pi. So in that case, let me divide this page and see. No, don't do that. So you can say PRT equals to this, then I divide both sides by E and T. E and T, because I'm looking for R. So T cancel T, E cancel P. I have only R left here. So I have R now. R equals to 100i, R equals to 100i all over PT over PT. So with that, I can say I have my rate here now, which is 100 times the interest is 4,000. Then the principal is 6,000, while the time is 2 years. So here I have 1,000. Then I have 100 times 4, that is 400. I have 6 times 2, that is 12. So I can decide to cut this down step by step and say how many 4 is here, that is 100, and how many 4 is here, that is 3. So I can now say how many 3 is in 10. 3 remainder 1 makes 10 again. How many 3 in 10? That's under 3 remainder 1 over 3 percent. That is at 33.5%. But I can leave it in decimal by saying 33 point. So how many 3 in 10? That is 3. 3 in 10 again. So 3, 3, 3, 3. Then just leave it at 33.3 or 33.33. So that is how to find that. Very quickly now we're going to look into compound interest. Whether you're true with the notes or not, don't bother, because we're going to let me clear the screen. Don't worry about the notes, you're going to get it through the video later. So that because of our time, we have to move to compound interest. So compound interest. Compound interest. So like we have for simple interest, we also have formula for compound interest. And the formula for compound interest is talking about amounts now. And why compound? Why are we talking about compound? For simple interest, we're talking about investing a particular money and it is yielding this amount every year. The amount does not change every year. The amount it is yielding, that means the interest, the profit every year does not change. So that is what it is yielding. But for the compound interest, we're going to have, if I invest for the first year and I get an interest, that interest is going to be added to the principal for the next year. So I will invest both the principal and the interest. So I will get more money now. After getting more money, it brings me another profit second year. I will add the profit to the new principal, that I started with, and still continue like that. So that is, but in order to do that, we have a formula, and the formula is A equal to, let me see that. So formula for compound interest. Now I'm still hearing some background noise. So A equal to principal into 1, principal into 1 plus R over N, 1 plus R over N, all raised to power N T, all raised to power N T. And this R, N, and whatever. So the A, let me change that to capital A because the formula represents capital A. So for this, it's going to be capital A. A, which is the amount, it's also principal. So A is the amount of money at the end of the given time, So amount. While P is the initial capital, initial money, which is the principal. And the 1 is just your number 1. So R is rate. And N is the time allocated to the rate. Maybe it's per year or per 3 months or whatever. So time No, let me just put it like that. Allocated to the rate, while T now is the number period of investment or period of trade. So I'm hearing background noise from Isaiah. Mute yourself, please. Isaiah, mute yourself. I think that's better. So T is the period of investment. Period of investment. Okay, so let's look at the one or two questions, then we round up. Let's assume you have, suppose you invest 10,000 naira at 8.15% interest. No, let me divide that. Suppose you have, let me see this text here. So suppose you invest 10,000 naira at 8.15 percent at 8.15% per 8.15 interest compounded monthly. Yeah, 8.15% interest compounded monthly. Interest compounded monthly. You know. Now say, how much will you have as your total money after 5 years? How much are you going to have? So we're looking for the amount now. How much will you have after 5 years? It's a question mark there. So here now, need to identify some of the terms that we have here. And this is the 10,000 naira is the principal. Okay, wait a minute. Let me select this. Yes. So the 10,000 naira now is the principal. It's the principal. And the rate is this. This is the rate from the formula now. So this is the time now. T. So this is compounded monthly. So because it's compounded monthly, mean our N is 12 months make 1 year. So because it's compounded monthly. So here now we're going to use 12 for this. This is for 12 months. Okay. So here now I'm going to have the how much time has been given, that's the 5 years. So amount is what I'm looking for. It's going to be according to the formula A into say A equals to B. So 1 plus R over N, then N and N T. So now the amount is unknown. That's what I'm looking for. The amount now go to my principal, which is 10,000. 10,000 into 1 plus the rate. And since the rate is 8.15%, we are going to change that to decimal from 8.15%. If I say 25%, what does that mean? It means 25 over 100. If I say 50%, it means 50 over 100. Is that taken? Now, if I say 8.15%, 8.15%, that is 8.15% divided by 100, and that will give me 0.15 Let me see. It should be 0.815. So 8.15 divided by 1. That is 0.0815. 8. Yes, that is 0.0815. So that's what I have there. 0.085. That would be my rate now. 0.0815 all over 12 versus 12 months now. That makes 1 year. Then the n is 12, so the n is going to multiply the time as well, and that will be 12 times 5. The power there, that will be 12 times 5. So 12 into the 5 years. So you need to press your calculator for this. This is no more simple interest, but just general multiplication and addition in mathematics. And if you press it well there, you're going to have 15,009.86. 15,009.86. So that's going to be 15,009.86. That's the amount after 5 years. So what you have to do is to divide this. That's 0.0815 divided by 12. Then you add to 1. Then you raise it to the power of 60. Then you multiply by 10,000. So you're going to need to press your calculator to get that. But this is the formula to use just in case you are given to find compound interest on a particular amount for a certain number of years or months. Let's look at one more question on the compound interest. Let's look at one more question. Let's assume you have to say how much. This question is how much would you have to deposit in a savings paying 4.9% annually so that you will have 6,000 in your account after 12 years. Wow. So let me clear this screen now as we go to the next question. So example 2 on the compound interest. So the example 2 says, how much would you have to deposit? See, how much would you have to deposit? How much would you have to deposit in a savings paying 4.9% annually? In a savings paying, I'm hearing some background noise. Probably you should mute yourself too. Then later when you see that there's noise, you unmute yourself. Paying 4.9% annually. 4.9% annually. That is the rate there. So paying 4.9% annually so that you will have 60,000 naira in your account after 12 years. So that you will have 60,000 naira in your account after 12 years. Now, if you look at this question very well, it's not asking us for amount this time around. It has given us the amount that you will have, which is 60,000 naira. That's the amount. So it's asking us for the principal. So So in this, guys, we have to look for how to make our principal associated with the formula, or just slot in all our values. Amount equals to principal 1 plus r over n, then n t. So let's say we have it again, amount equals to principal into 1 plus r over n, then principal n t. Here we have the amount to be 60,000 naira, so I have 60,000 naira. 60,000 equals to the principal that I'm looking for into 1 plus my rate is 4.9%, so I need to change 4.9% to decimal, and that will be 4.9 divided by 100, and that's 0.049. So I have 1 plus 0.049 all over the number of the number that I'm going to use, because it's 1 year now. I mean, it's annually, not monthly. If it's monthly, I'm going to use it for 12 months. So, but here now, I'm going to use annually, which is because of this annually, I'm going to use 1 to represent it. So, then raise to power this same 1 times the number of years I was given, which is 12 years. So here now, you're going to have your 60,000 P into 1 plus, this divided by 1 is just, so I have 1.049 over 1 raised to power 12. Raised to power 12. And here now, I have to divide both sides by 60,000. Divide both sides by 60,000. So this, oh no, not 60,000, because I'm not looking for 60,000. I'm looking for P. So I have to divide by what it's coming. So I have to divide both sides by this figure here. So it's 1.049 exponential 12. And here also 1.049 exponential 12. So this cuts this, so I have my P left. So P is now equal to 60,000 divided by this value 1.049 raised to power 12. And again, you have to press your calculator to get the power 12 of this, and you divide 60,000 by what your result is, and that's going to be 33,795.20. That will be 33,795.20. So that will be the principal. So you must invest a principal which is this amount, 33,795.20. Yes, if you must have 60,000 in your account at the end of 12 years for a saving that is paying 4.9% interest annually. Okay, so Isaiah, do you have any question? That you can unmute yourself and talk. There's no nonsense. So, and then your last, any question?
No, sir.
Oh, okay, so that is where we're going to be calling it a day for today. So, thank you very much for joining the class. I will try as much as possible to make the video available so that you can have the full notes. So, we're going to be ending. Thank you. So, have a nice day ahead. Bye. Can I say goodbye? Okay, bye-bye.
Bye, sir.
Even